Let's try this advanced level question. Consider a mountain which can be modeled as flat inclined surface. A projectile is launched up the hill of the mountain so that it moves in air during the time interval 3 seconds before hitting a target at the surface of a mountain. It is also known that vectors of velocities of this projectile near launching and landing points are perpendicular to each other. Okay, let's analyze this situation. The mountain hill can be assumed to be an inclined surface as we can see, right? And ball is projected up a hill of the mountain so that in air during the time interval t 3 seconds. So this ball when projected up, it moves in a projectile motion and it takes time 3 seconds, right? Okay. And it is also known that, okay, initial velocity vector u just before launching and just before hitting the mountain surface, this velocity vector are perpendicular to each other, right? As we can see from the figure. So, okay, in the question it is being asked, okay, so they're asking value of L. Okay, let's analyze the situation. This this problem can be solved through different methods. One method which we can use is through vector method. Okay, let's say let's say the plane of inclination of this mountain is alpha and ball is thrown at angle theta with the plane of inclination, right? Theta and alpha. So if I take this in a coordinate system xy, I can write velocity initial u vector, okay, in terms of component. This can be written as u cos theta plus alpha I cap plus u sin theta plus alpha j cap, right? If I break the component of initial velocity vector in x and y coordinates, this can be written in this form. Okay. So my g vector acceleration due to gravity in terms of vector can be written as g minus j cap. Time is given, that's 3 seconds. So my velocity vector, first I have to find that. So we know this formula, velocity vector is equal to u vector plus a vector times t, right, from equation of motion. So my v vector can be written as u cos theta plus alpha I cap plus u sin theta plus alpha j cap, right? Plus a vector, that is acceleration due to gravity. This can be written as g minus j cap times t, right? So t value is given, that's 3. So it's 3g. More precisely, this can be adjusted and written as, this is j cap, u cos theta plus alpha I cap plus u sin theta plus alpha minus 3g j cap. Okay. Okay, I got this. If you see in the question, analyze the situation, my u vector and v vector are perpendicular to each other, right? So I can take a dot product. I can write v vector dot u vector since they are perpendicular. So this will be 0, right? If I simplify this, v vector, if I simplify this, my v vector is u cos theta plus alpha I cap plus u sin theta plus alpha minus 3g j cap and its dot product with u vector, and u vector was u cos theta plus alpha I cap plus u sin theta plus alpha j cap, and this is equal to 0, right? Let's simplify this. This can be simplified to be u cos square theta plus alpha, right, plus u square sine square theta plus alpha minus u sine theta plus alpha times 3g, and this is equal to 0. If you see these two terms can be adjusted to u square, right? Because cos square theta plus alpha plus sine square theta plus alpha is equal to 1, right? So it's u square minus u sine theta plus alpha times 3g equals to 0. From this, I can get the value of u is equal to 0, and u is equal to sine theta plus alpha times 3g. Right? Okay. One relation I have now. Now, and I was required to find the value of L, right? Okay. So I need a relation between L. Okay. I need to find a relation. If you see here, this is my L, right? If I want to express, and this is my net displacement during this motion, right? So this is my net displacement during motion. Okay, so from equation of motion, I know that S is equal to ut plus half at square, right? So my displacement vector S vector, that is position vector of this, can be written as, since this is L and the angle of inclination is alpha, so x coordinate can be written as L cos alpha, comma L sine alpha, right? So my displacement vector I got. So this can be written as L cos alpha I cap plus L sine alpha j cap, right? In terms of vector, this is equal to u vector times t. So u vector I had u cos theta plus alpha I cap plus u sine theta plus alpha j cap times t, and t value is 3, plus half acceleration due to gravity was g minus j cap t square, that's 9, right? Okay, so this can be further simplified to be L cos alpha I cap plus L sine alpha j cap. Okay, so this is 3u cos of theta plus alpha I cap plus 3u sine of theta plus alpha minus 9 upon 2 g j cap. If I compare both sides, comparing both sides, I can say that L cos alpha is equal to 3u cos of theta plus alpha, and L sine alpha is equal to 3u sine theta plus alpha minus 9 by 2 g, right? Now if I square both and add it, squaring both and adding, this will give me L square cos square alpha is equal to 9 u square cos square theta plus alpha, right? And this L square sine square alpha is equal to 3u sine theta plus alpha minus 9 upon 2g whole square. Add these two values. If I add this will be L square cos square alpha plus L square sine square alpha equals to 9 square u square cos square theta plus alpha plus 9 u square sine square theta plus alpha plus 81 upon 4 g square minus 3u sine theta plus alpha 9g. 2 and half will get cancelled, right? Further, this can be simplified to be L square times 1 cos square alpha plus sin square alpha is value 1 is equal to 9 square 9 u square cos square theta plus alpha plus 9 u square sin square theta plus alpha. This can be simplified to be 9 u square times 1, right, plus 81 upon 4 g square minus 3u sin theta plus alpha times 9g. Okay. This can be written as L square equals to 9u square plus 81 upon 4g square. If you see 3u sin theta plus alpha, I got this value, right? U equals to sine of theta plus alpha times 3g. This can be written as, this can be adjusted to be 9u times 3 sine of theta plus alpha times g, right? So this 3 sine theta plus alpha times g can be substituted with u. So this is L square equals to 9u square plus 81 upon 4 g square minus 9u times u, right? So this becomes L square 9u square plus 81 upon 4 g square minus 9u square, 9 square 9u square cancelled. So my L square is equal to 81 upon 4 g square. So L value is 9 by 2 times g, and this is equal to 44.1 meter.